I'm very privileged to be able to give a quick overview of how Digital Promise is thinking about computational thinking right now. We just published a new report in December called Computational Thinking for an Inclusive World. It is meant really for educators so that to help speak to educators about what computational thinking is and start getting conversations going about how computational thinking can be implemented in the classroom in a way that is inclusive and helps all students to be able to take part. We know that computational thinking skills are really important for everyone to engage in our increasingly technological society, and it's not just for computer scientists. And so computational thinking is something for all of our students, whether or not they want to program a computer or not. But we also know that our educational system has historically prepared only some students with computational thinking skills and has systematically excluded other student populations. So our call is for all educators to integrate computational thinking within disciplinary learning across K-12 education, and while centering inclusivity to equip students with the skills that they need to participate in our increasingly technological world and to promote justice for our students and really for society at large. And so that's what we want to invite you guys to discuss today. Just as a quick overview for those of you who are new to computational thinking, computational thinking and computer science kind of live in this world of computing, but they're overlapping but separate. There are some parts of computational thinking that aren't computer science. There are some parts of computer science that aren't computational thinking. So they're not one and the same, but they do have some overlap. Particularly part of it is programming, but we do kind of emphasize a Digital Promise that computational thinking isn't about only coding. It isn't about only computer programming. It's about a lot more than just that. And we break it down into a set of computational thinking skills and a set of practices. These are things that I'm sure you'll hear our panelists talk about today, things like algorithmic thinking and how that leads to automation and computer programming, things like computational modeling and being able to use computational models and simulations to learn, and also data. There's a really important part of computational thinking that's looking at and analyzing data. And at the center of this, we have inclusive practices, and we kind of put these into three buckets. One is designing accessible education, another is combating inequality, and a third is connecting to students' homes and communities. And in our report, we share this image as well with kind of what are some different ways to do that. And we'll talk about that with our panelists as well. So I want to back up. You're not here to talk to me. You're here to talk to our educator panel. So it's my pleasure to introduce our panel today and have them be able to share a little bit about what they've done. So Sunny, can I have you start by just introducing yourself, where you're from, and what you've been doing with CT?
Welcome, everyone. Good morning. My name is Sunny Rodriguez Mena, and I'm originally from the Dominican Republic. I've been living in the United States for about 30 years now. And I teach in the Bronx. I teach students with special needs from K through 6. However, the most of my years as an educator, which is like now 23, I have been working with kids in 1st through 3rd grade, but most recently 1st and 2nd graders.
Awesome, thank you. Jessica, can I have you go next?
Hi, good morning, everyone. My name is Jessica Bibbs Fox. I teach specifically 8th grade on a K-8 campus. Actually, it's a TK through 8th grade, even though I don't see the little ones that often. I've been teaching for over 18 years. 2 of those years, I was outside of the classroom as a curriculum specialist. I've served in many different roles, from tech lead on our campus. I'm really passionate about being self-driven with my professional development. So I have a lot of micro credentials. I'm an Apple Distinguished Educator. Have California Distinguished Awards. So all of those things just to say that I am an educator in the school district that actually raised me, which is in Compton Unified School District, born and raised there. Actually, my first 12 years of teaching, I taught in the same classroom where I attended 5th grade. So that was pretty cool. And yeah, I work with a high population of low income, free and reduced lunch in the center of Los Angeles, because that's why Compton is called the hub city. We're right in the middle, smack dab of LA County.
Awesome. And last but certainly not least, Ellen. Oh, Ellen, you're still on mute. If you can unmute, that'd be great.
Thank you, dear. So I'm Ellen, and I've been teaching for 35 years, math and computer science, more recently now more computer science, as our district has wrapped its head around computational thinking. I've been teaching in a wide range of schools, from very small rural schools, very disadvantaged schools, to private girls' schools, Catholic education schools, to high-powered public schools. The school I'm in right now is very small. We're a K-12 building. It's actually the high school that I attended. It's the district that I grew up in. And it's pretty much where I'm ending my career. But to echo my other fellow panelists, I do believe in being self-driven in my learning. And that's why I love participating in these sort of ventures. And I'm happy to and share some of my experiences with CT in the classroom. So I'm happy to be here. Thank you.
Great, thank you guys so much. I'd love to start by having us understand a little bit more about the role that each of you guys has played in the work. And so we're going to start with a question for Sunny. Sunny, you're a special education teacher who works with first, second grade students. Can you share some strategies that you have for integrating computational thinking with your neurodiverse students?
Sure. So in my experience, all students, especially those who have certain needs, special needs, and also students who are second language learners benefit a lot from visuals and for different multisensory approach when it comes to learning. So in my practice, I usually have a lot of visuals. So one of the things that we do in the classroom, I'm happy to say in my school, this computational thinking initiative has been taken school-wide and everybody is participating. So in terms of what you were talking before, that there's some kids who are not exposed enough, like I have to be proud to say that in our school, kids from kindergarten all the way through 6th grade have been exposed and have the same access to computational thinking. So it's generated for everybody. So everybody is on a common place. So we use a lot of visuals. One of the visuals that we're using come from Barefoot Computing in the UK. So we have adopted and modified with their permission their icons so the kids can relate to the concepts and approaches to computational thinking, and they can familiarize it through some visuals. Another thing that I use in my classroom, and it's not only in my classroom, in the whole school, all the classroom has posters with the icons and the concepts and approaches to computational thinking. And in my classroom, I like to use a lot of movement. I work with little kids. They learn through songs. They learn through playing games. So for example, if we're talking about logic, you can go into my classroom and say, how do we use logic? To understand. So they touch their head, so they know that they're using logic to understand any problem that they're working on. Another thing that I use also is like we use the vocabulary and we try to make it as real as possible. We make the concepts and approaches relatable to their everyday lives, because computational thinking is not only for computing. It can be applied to any area, not only subject and academic areas, but also in our real life. For example, if I introduce the algorithms, an algorithm is just a set of instructions to complete a task. So I stop giving directions when I'm assigning any activity. So I give an algorithm instead. So they know every morning we use an algorithm to get set up for our morning work. The first step of the algorithm, we take our jackets off and put it in the closet. Second step, we take our materials to do the morning work, and so on and so forth. So it's making it real so the kids can relate to that. So that's some of the things that we do in our classroom and also in the school. Another thing that is very important is the teacher and how the teacher approach this. The more you use the vocabulary and the more natural you use it, the more the kids are going to absorb it. So using, like, for everything, for example, I had a first grade class and we're talking about collaboration. So just beyond the classroom, we were walking to the cafeteria to have lunch. The doors, some of the doors are very heavy because we have a very old building. So there was the leaders of the line were trying to open the door. And I hear from the back, one of the students said, you have to collaborate. So it means that they have to work together to solve that problem. So computational thinking goes beyond just computing and computers.
Awesome. Thank you so much for sharing, Sunny. Jessica, I have a question for you next. You've provided your students with opportunities to not only develop computational thinking skills, but to do so while considering real world and life relevant events. Can you share some strategies that you have for integrating culturally relevant and critical topics into computational thinking lessons?
Sure. You're going to see me look down at my notes only because I can talk a lot. So I'm going to try to stay focused here, okay? Strategies is really what is the most powerful thing in integrating computational thinking. So for me, the very first strategy that you have to have is that you have to know your students. If you're going to make something culturally or relevant to their lives, you have to know their lives. You have to know what they're dealing with. You have to stay in tune. And so often, as I mentioned earlier, I'm from the area, but I also recognize that I'm in my 40s and from a whole different time period. So I try to make sure that I use strategies to keep open lines of communication with my students, whether that's having our class Instagram, making sure that we have weekly polls and check-ins, and keeping a way for us to build those relationships with one another is very, very critical if you're going to integrate computational thinking into relevant lessons. And then secondly, you want to have exposure. So sometimes we take for granted things that we know as adults and that we know what's going on, and that we think that kids or our students are also in this loop of knowledge, but they're not. And so exposure to events, making sure that you give them opportunities and a platform for voicing what they know, and you'll be shocked of what they know and what they don't know, or what they've made sense of. And so you have to have a structure within your classroom, whether it is something where you can just have daily check-ins. Hey, tell me what's going on local on TikTok. Tell me what you just learned. And then also reciprocating that back and saying, hey, let me show you what I've heard. Maybe you have a bulletin board in your classroom where you drop those news events, where you drop those type of things. That strategy allows one for the kids to see you as not just a person who's giving a lot of information and telling them what's going on and what's relevant, but also that you also want to know what's relevant to them too, right? And that there's this interchange of information between you two. When you build that type of relationship and have that type of exposure, it makes it so much easier and so much more powerful or meaningful when you then start to connect these type of higher order thinking skills of computational thinking to the projects and things that we're working on. Then other things, I am in a district, as most of us are, that has a set pacing guide, has set standards that I have to be teaching at a certain time, at a certain day, and have a test for, right? That's the majority of us who are in public education, especially here in California. So another strategy that I have is that with all that being said, I am very cognizant of that I need to make connections with the people who are setting those pacing guides, that I'm very aware that I need to build relationships within, the central office. I know that I'm in the classroom, and instead of just being the receiver of, hey, this is what I'm told to do, like having those open conversations in a very respectful way, of course, but allowing us to have some freedom in saying, what is it that the objective is? Because if you're clear on what your objective is, then regardless of the curriculum, you're able to then go and find good curriculum, right? Find those pieces that you can then build together and make those connections. And so what I have found a strategy in building around and navigating between my district requirements and trying to do culturally relevant things in the classroom is to really think about the universal concepts and really think about the skills and the processes that I'm trying to teach, right? And if I keep it simple and really make sure that I understand, which I try to teach the kids too, is that all you're really doing is learning some basic comprehension. You're learning skills that you can transform to anywhere. I always use the analogy of my father, who told me, if you can drive a stick shift, you can drive any car, right? And so that's kind of the idea, or my way of thinking towards with my students. Like, I'm going to teach you how to think. We're going to not teach you how to think, but I'm going to teach you these skills and these strategies. And if, as a teacher, that's my strategy of addressing my objectives for the day, then I can then tie everything in together. And in order to do that, with computational thinking, we have to build those connections outside of the classroom with people who are in those professions. So we worked on that when we first started in COVID. We did this COVID project. I asked the kids if it was great. I built it out with help from a lot of different people, from Digital Promise, from Apple specialists. But this idea of building networks, which allowed us, and part of that project where a doctor came in and the students interviewed the doctor. right? To get this, to get questions answered that they were having. And that's only possible if you're building connections outside of the classroom. So using social media, using different platforms and organizations such as Digital Promise, the Apple community, all the different networks that exist out there, and putting yourself out there. So if you have that strategy of putting yourself out there, then other people, other educators from around the world, just like with these Edcamps, you can build a platform of people that you can bring into your classroom. And the more that you bring people into your classroom from the things that you're studying, the things that are the topics that you are critically analyzing, it makes it more relevant, and it allows a student to see that those computational skills, such as, can you really decompose this problem? Can we look at this from abstraction, right? And then it makes more sense. It's like, this is not something that's just linked to a computer. This is a way of thinking about all types of problems. This is a way of thinking about anything that we're addressing. And then lastly, again, a main strategy is mixing and choosing good curriculum with good curriculum. That's my last note to answer that question.
Thank you so much, Jessica. And finally, Ellen, you have had extensive experience integrating computational thinking into your math classes. Can you share an example of how computational thinking has supported your students' understanding of math?
Sure. So I don't know if you're familiar with this classic problem. It's the Tower of Hanoi problem. So what is the objective of this problem? So this problem has a disk of 7 towers, and the objective or the solution would be, can you move the disks from one peg to another, transitioning them all according to some rules? One disk can move at a time, and a smaller disk is allowed on top of a larger disk, but we're not allowed to put a larger disk on top of a smaller disk. So my problem 2 is, how many moves will it take to move a tower of 7 disks to another peg? It has to be minimum number of moves. So you might ask, like, where would I use this problem? In Algebra 1. In Algebra 1, we follow Common Core in New York State. Sequences is a unit of measure, a unit we have to do and work with. So is recursion in sequences. So this problem offers a rich opportunity for me to do all those things, right? Recursive thinking, heuristic reasoning, trial and error. But then I began to look at this problem differently as I started to work more on computational thinking. I began thinking that this problem opens up so many opportunities for, you guessed it, pattern recognition, decomposition, making the problem easier to understand by maybe removing all the disks and seeing if you can solve it for 2 disks. And then maybe layering on top of that as we begin to build the model, can I do this for 3? And if I can do that and begin to see patterns in the work and in my thinking, perhaps I can extend this model to a formula. Maybe I can apply some rules of abstraction to this. So my learning is I took a problem that I've been doing for years and began to look at it in a CT lens. I really believe in framing the work with the names of the practices, the CT practices that you're using in your classroom. You're probably already doing this and don't even realize it. So this problem has just grown tremendously, and I actually use it in my geometry classes as well as we build models in geometry, shapes, fractal pop-ups. If you want to know more about that, reach out. That connect to this model, where we built a model in geometry to actually represent the solution to the Tower of Hanoi, the actual physical number of moves that a student has to make. So the pattern recognition, the opportunity for algorithms, abstraction, decomposition, modeling, data visualization was all packed in this problem. But it wasn't until I really began to get familiar with the language of CT and CT behaviors and practices that I began to frame this in a different way. So now my students, to also acknowledge my panelists here that said some of the same things, that I'm now hearing that language come from my students when they work as collaborators. I actually heard it the other day in my geometry class where kids were doing proof. And they actually said, I couldn't believe it, how they had to decompose it into smaller pieces. It's like, whoa, you get an eraser. So it just was so exciting. But I think what I can give is advice for all of you that are maybe looking for a way to do this and not seeing it as one more thing to do, but to maybe acknowledge that you're already organically a CT thinker. And I saw in the chat, someone had mentioned, like, how does this connect to innovation or to an innovator? An innovator by design, I really believe is a hidden CT thinker. that their heuristic reasoning of trial and error, getting an idea or innovation to work, they've got to debug, they got to replan if they fail. I think for sure that an innovator is a hidden CT thinker. So anyway, that's what I got to say about that. But there are so many opportunities if you look at your curriculum and good problems to solve for students that you can frame around the CT practices. It would be my greatest advice. That's it.
Awesome. Thanks so much, Ellen. We're going to now move to a couple general questions for the panelists. And while they're answering this first question or two, I invite everyone to keep engaging in chat. And if you guys have questions for the panelists, please drop them into the chat. We've reserved the last 10 minutes of our time together with our panel this morning for your questions. So please start dropping those in chat. My colleague Kelly is going to be compiling them, and so we'll have those questions up next after a couple that I've prepared. So the first general question is, over the last 2 years, classrooms have looked different than ever before, from Zoom to social distancing. The COVID-19 pandemic has caused many changes to teaching practices. How have you integrated computational thinking in a blended or online learning environment? And we're going to start with Ellen for that question.
Hi. Yes, certainly it was challenging to continue this work for sure. When we first went all remote in March of 2020, I really leveraged the technology of Jamboard to get students really working collaboratively on solving a problem. So that I could actually see a lot of the voices of others that normally would be kind of quiet in my room. So I leveraged that big time, but also Pear Deck. So I could also watch what they were doing, you know, try to ignite some of their thoughts as they were moving through the slides that I might have prepared for them. So for me, that leveraging the technology was important, not to change my problem. So like you might be asking, well, how did you do the Tower of Hanoi? These are physical puzzles. Were you concerned about, you know, kids touching these things? Of course, but they can certainly make their own puzzles with coins. So you can be creative in how you approach these problems as an educator, or find digital representations of the same models and putting that all together. Now in the hybrid environment that we were in last year, I did some of the same thing. And my problem solving still looked the same, but in a wider lens and leveraging technology to help with hearing all those voices. Now we're all back in person, and I really am still leveraging, in particular, Pear Deck, because it does give me a nice opportunity to hear voices so that everyone has a chance to participate in these classroom activities and environments. So leveraging the technology was really big, and trying to see the problems that you're giving students in just another way. Instead of that paper pencil whiteboarding, that whiteboarding became the Jamboard or the Pear Deck slides. So that's kind of what I did. Pear Deck, yeah, is awesome, Christina. Yeah, definitely awesome. I love it. Wouldn't change. Would never not use it again. You really so the kids that feel they can't participate or don't see themselves as these CT thinkers really do get to shine. So it's key.
For me, the last 2 years have been definitely challenging as an educator, and just personally, I've been to like 20 funerals this over the last 2 years. And so one of the shifts that we made over this course of the pandemic was looking at real data in real time. And so what we look at, I started to use is Our World in Data. It's a phenomenal website. It has large amounts of data that students can then analyze. So I don't know if I mentioned earlier, but I teach an integrated math and science course, 8th grade. And so anytime that I can pull those two worlds together is awesome. And so we started using more of the tools that were already on our iPad, Numbers, Google Sheets, those type of spreadsheet type of documents, and really understanding that you don't necessarily have to have all these different platforms to do great computational thinking when you're dealing with real data. And so a lot of the times looking at that data, being able to process it, pull out those type of conclusions that we can pull out from them. It can be done just with simply using your internet and I'm going to websites that are collecting this data. And it's a phenomenal, once you teach teach kids those skills, they can then start to evaluate and judge what kind of information that they're reading, if it has data to support it. And for me, that's like, you could tell propaganda from any kind of stuff. Because if you are asking those type of questions, which is a computational thinking skill, looking at data, being able to analyze it, being able to break it apart and figure out what it all means. And even when we were online, that's how I started, because I needed to just send them links and stuff versus just, I was used to, prior to that, we're going to collect some data in class and just manipulate this. So it became more relevant, and I've continued that this year. We're all fully back in person with some students out because of, the COVID situation, but it still is accessible to have these type of data. Also using New York Times, what does the graph say, right? Looking at graphs that are already out there and then trying to figure out what they actually are. So using those tools in the classroom is something that I've integrated and continue to integrate in my math and science course.
Well, in last year, I was teaching fully remote to first and second grade students. It was, I have to say, there are many challenges, but there's also the beauty. And as I said before, when we're talking about computational thinking, it's not only about computing and computers, it is about everything. So the computational thinking is a set of vocabulary words that the kids can use. It is a common vocabulary that kids and teachers as well use to intentionally label the process, our thinking processes. So that's what we did when I was teaching fully remote. We had the same vocabulary usage. When I was teaching, for example, teaching phonemic awareness to my students. So, okay, let's see with the word families, we are looking for patterns. So we are addressing pattern recognition right there. When we're working in math problems, okay, let's decompose. Same thing when we're teaching reading, we are decomposing here. Let's decompose this word into phonemes. So we can have one sound at a time and then blend them together. So it was a common usage of the language all the time. So it comes natural, not only for me, but also for the students. And another thing that I implemented is, like I said before, I like to use a lot of visuals. So in our school, we use the barefoot computing visuals and icons, but we adapted and modified, as I said before, with their permission, so the kids can be more familiar, things that are more, that can relate more. So we changed some of the icons and we call it the CT toolbox. And if anybody's interested, I can definitely give that resource to the organizers of these events, and you can definitely can share with them. So in the beginning, it's a lot of modeling from my part. So I am using the language, I am modeling how to use it, and I'm also, like, for example, we do a reflection, a CT reflection at the end of every lesson, whether it is science, math, reading, or it is any subject that we're teaching, social studies. So the thing is that we go, and I display the images of the different icons according to the CT skill that we are working with. We're working with, we introduce it one at a time. And we digest that one, and we give multiple examples and get the kids used to that vocabulary, the new vocabulary word that they are learning, and let them apply it. So we introduce one at a time. After all of them are introduced, we display it, and I have the CT toolbox display at the end of every lesson. So which CT skills did we use today during this lesson? So that's how we start our reflection. And the kids say, oh, we use debugging. How did we debug today? Because that's the thing, I want to go beyond just saying, oh, we use it. But now I want to know that they really understood what that meant and how they apply it into a specific lesson that we were working with. So, oh, we debugged it because when we were reading, we had that word that was wrong, and we went back and reread that word and we debugged it, so we fix it. And in the beginning, as I said, it was me starting the reflection and modeling for them. Later on, the kids will start the reflection without even me saying anything to them. They will say, oh, we persevered today. Oh, how did we persevere? Oh, because we didn't give up. So they will start it. So we will show the CT toolbox, and then we will be checking off all the skills that we use. And sometimes the students might say, one student might say, oh, we applied this skill. And another one said, oh, no, we didn't. You want to hear both of them and the rationale. That's why I always ask, how, why? Why do you think we use that one? So that way, because sometimes like we are just focused on one thing and we don't see the thinking process. So computational thinking skills provide the students with a tool to express their thinking process whenever they are solving any type of problem. So during my teaching remotely, it was really used the same as it was used as I used it in the classroom when we are in person.
Awesome. Thank you so much. We've had some great questions in chat, so I want to make sure we've got just a few minutes left, but that we can start talking about them, and then we can continue these conversations in our sessions. So a question came from Greg Bagby, who asked, where can we find unplugged resources for computational thinking? I know a couple things have been shared in chat, but in a minute or less, do you guys have any unplugged resources you guys would suggest?
Yeah, I typed into the chat csunplugged.org, and I've used those definitely in class, especially in my computer science class where they just want to jump into using the device. These are really healthy to do.
And I'm a fan of looking at the current curriculum that you're using for your math and your science. And once you know what the CT standards are, looking for ways that you can actually just label the things that you're probably all, like Ellen said earlier, you're probably already doing some things and then labeling them with those CT practices and strategies.
In our school, we also create a lot of those strategies. We have some coaches in the school, and we have the fortunate experience to work with some of the mentors from Cornell Tech, and we have been able to create a lot of those unplugged activities, actually, to make sure that we can provide our students with experiences that they can relate to.
Great. And one more question came from Dave Z, who asked, how do you incorporate hardware of any kind, including paper or cardboard, in remote learning? I don't know if the three of you have had any experience with that, but if you want to share, if you had.
So
Go ahead, Jessica.
So last year, as the science teacher, it was impossible to do a lot of the labs virtually. I was spinning my wheels. There's a lot of simulations out there, but sometimes you need to just have the hands-on materials. So I did package up all of the materials. We went on Amazon and went on a buying spree and made grab to go little kits for the students, put them in paperbacks, and then had them come through as on a schedule to come and pick those things up. And then also what we did initially from the very beginning of the year is that we created a task. It was kind of like a scavenger hunt where the kids had to have a box at their house where they basically collected upcycling material. So that egg carton that your mom was getting ready to throw away, keep it. You know, if Amazon package came with the bubble wrap, keep it. So it became like a fun act. And then every week we would kind of just share out the things, our great finds for upcycling. And then they built their own little boxes too from trash that would have.
In our school also, we prepare some packages for the families to come and pick up. So we were able to provide some materials, but the same thing as Jessica mentioned before, we also asked the kids to be creative and to use materials that they have, like, recyclable materials that they can use and create things.
I did, I made these Sierpinski gasket kites last year. I know I'm geeky, whatever, has to do with fractal geometry, but actually connects to my puzzles. And I made little kits with just tissue paper straws. I went to Michael's and bought a lot of like the thinnest gauge, like 30 gauge fluorescent wire. And I made videos on how to put these kites together. It's really simple. It's a simple algorithm, connects beautifully to geometry. And then you have to fly them and film yourself flying them. So it was really cool. The kids that happened to be hybrid and with me, we all went outside. It was great. I wanted to get them outside as much as possible. And I wanted to get them away from, the keyboard and away from the screen time. I wanted them to be, working with their hands as they could. And it was really, really fun. And it just brought joy, joy back into the classroom and watching my kids be little engineers and watching the girls in particular. One girl, Amanda, adore her. It was the project that changed her pathway of thinking. And her mom reached out to me and said, my daughter now wants to be an engineer, because hers was the only kite that flew like beautifully right away off the bat. It was awesome. And I didn't tell them everything of where to tie the string to leverage the balance. These are tetrahedron kites. They don't balance, like they just don't. But the way she tied it was beautifully thought out and so creative. It was great. So now she wants to be an engineer. So you never know what one little problem you might give a student to solve that would turn their mind another way, another path. So yeah, leverage that. I also leverage Canva to do like information posters or like a digital information poster, infomercial type thing, where they had to create an infomercial about a process to find the vanishing distance from their height where they are in their latitude and longitude to how far they could see to the horizon. So they had to create and design, bring those CT skills again, like what will make this poster pop? How should I organize my information, for others to read and collaborate with? So yeah, that's what I did.
Awesome. Well, thank you so much to our panel. We have run out of our panel time, but I'm so excited because it means that we have started such great conversations that we can continue in our breakout sessions today. So thank you guys for sharing these thoughts and these ideas and getting us started. And I'm going to stop the recording right now. So the rest of our Edcamp will not be recorded.